Hi guys, welcome to my NBT training session. Let us have a look at some of the questions that will be beneficial to you in the NBT 2021 examination. Right, so I've compiled 10 questions here from past papers, right, which will be beneficial. So we're looking at trigonometry specifically. Let us have a look at question 1. Given y is equal to cos x, the line y is equal to negative 0.5 passes through the points A and B. Find the x coordinates of A and B. So let us find the coordinates of A and B. In order to find the coordinates of A and B, we know that this horizontal line here goes through the point, the y value, which is negative 0.5. So we can equate both the graphs at point A and B. So what we can say is cos x is equal to negative 0.5 or negative half. Okay, now remember we want to work out the coordinates of A and B. This 180 degrees is basically here. This is, if looking at the graph of y is equal to cos x, that's 90, that's 180, that's 270, and 360 is there. Same story here, 180 and 360 is there. Right, we can clearly see that this value of A is just more than 90 and this value of B is between 180 and 270. But anyways, let us solve this equation here. So obviously we say a reference angle is equal to cos inverse half. We know that this is a special angle, so that should give us 60 degrees. Now we ask ourselves the question, where is cos negative? So in the cast diagram, cos is negative in the second and third quadrant. So quadrant 2 will give us 180 minus the reference angle. So x is equal to 180 minus 60, which is 120 degrees, or quadrant 3 solution is 180 plus 60. So x is equal to 180 plus 60, which is 240 degrees. So the x value, so the coordinates of A is basically 120 degrees and minus half, and the coordinate of B is 240 degrees and minus half. Now let us move on to question 2. So we wanted the x value, so we can just stop here. So x is equal to 120 degrees or x is equal to 240 degrees. Question 2, tan of 315 minus tan x times sine of negative 2x. Now tan of 350 degrees, 350 degrees is basically in the fourth quadrant. So we can write down in the fourth quadrant tan is negative, so negative tan 45 degrees. Now remember, sine of a negative angle, sine of negative angle is basically equal to negative sine of the angle. Right, and tan of negative angle is also negative tan angle, just that cos of negative angle remains as cos positive angle, because these negative angles are usually in the fourth quadrant. That's the reason why sine is negative, tan is negative in the fourth quadrant, and cos of negative angle, that's negative tan angle, right? And cos of negative angle is basically the only one that's positive, because these are all in the fourth quadrant. Cos of negative angle. Why it is in the fourth quadrant? Because we have the cos diagram. If you go in this direction is theta, and if you go in this direction it is negative angles. If you go in the clockwise direction it is negative theta. So if I replace all these with negative theta, you can clearly see sine of negative theta is in the fourth quadrant. So if we want to find sine of negative 2x, remember the negative and the negative becomes a positive. So positive, since that became a positive, remember sine of negative 2x. Okay, I'd rather do this. Let's keep this as negative. Tan x is sine x over cos x, and sine of negative 2x is negative, and sine of 2x, we left with sine 2x, 2 sine x cos x, because sine 2x is a double angle. Remember the expansion for this, right? Negative, sine of negative angle is negative, right? And then you will be left with negative sine 2x, and then sine 2x is 2 sine x cos x. You can clearly see that the cos x and the cos x cancel out, and we are left with minus 1, negative and negative, which is plus 2, and sine times sine is sine squared x. And negative 1 plus 2 sine squared x, this here itself looks like a double angle, right? Double angle for which graph? For cos. So we can, if we take out a negative, then we can get negative into 1 minus 2 sine squared x, and 1 minus 2 sine squared x is one of the forms for cos 2x. So if you write down cos 2x, remember cos 2x is basically equal to cos squared x minus sine squared x, 1 minus 2 sine squared x, and one more, which is 2 cos squared x minus 1. These are the three expansion for cos double angle. So what is this 1 minus 2 sine squared x? That is just negative cos 2x, right? Obviously guys, you will be given multiple choice questions, so you need to select is whether if it's A, B, C, D, right? So in this case the final answer is minus 2 cos x, minus cos 2x, so you need to go and select the correct option. Question 3, we want to find the period of f if f of x is equal to 3 minus sine 4x. Now just to do some rules quickly, remember the general period, if period of just say if the function is y is equal to a sine bx, right, or a cos bx, whether we have sine or cos, the period is always equal to 360 degrees divided by b, right? That's the period of the graph. And if we have y is equal to a tan bx, something in this form, and the period for tan is basically equal to 180 degrees divided by b. So if we want to solve for the period of 3 minus sine 4x, remember the shift in the graph, this plus 3 over here basically means the sine 4x graph is shifted 4 unit up. If the graph is shifted left and right and up and down, it will not affect the period of the graph, right? Period is basically one wave. So in this case, sine 4x, we can just find the period. So therefore the period of this function over here, therefore the period is now equal to 360 degrees divided by 4, and that should give you 90 degrees. Remember, you are not allowed to use a calculator, so you need to remember special angles, double angles, compound angles, right? All these basic rules. So let me just highlight this. This is just your rules here, right? Just to remember that. Let's look at the next one. The range of f, guys, the range of f of minus 1 minus 2 sine 2x. Now remember, we can find the range of sine 2x, right? Or 2 sine 2x. So since this is the amplitude, right, the height of the graph is 2, then basically the sine graph will oscillate between, the sine graph will be wavy or oscillate between minus 2 and 2. So the range of 2 sine 2x, so the range of y equals 2 sine 2x is basically is an element, y is an element, let's just write this down, y is an element from minus 2 to 2. In other words, the minimum value is minus 2 and the maximum value is 2. Now remember, from this graph we're shifting this entire graph 1 unit down. The minus 1 basically means we're shifting the graph 1 unit down. So we can take away -1 from here and -1 from here, because the minimum and maximum values will change when you're shifting the graph up and down. Therefore, the range of f, this is the function, full function, the range of f will now be y is an element from -3 to 2 minus 1, which is 1, right? Whereas remember, these are defined values. In other words, this is the min value, so they can also ask you for the min value of f of x. So this is the min value, and that's the maximum value. But since we want the range, it's between -3 and 1, so therefore writing it in inequality notation, it will be -3 less than equal to y less than equal to 1, where -3 is the minimum value and 1 is the maximum value. I hope you understand, guys. Let us look at question number 5. We have y is equal to 2 sine squared x minus 1. The period of y equals 2 sine squared x minus 1. Now this is great because we have 2 sine squared x minus 1, and this here looks like a double angle, but remember, not in that form. So if we take out a negative, then it will look like a cos double angle. So 1 minus 2 sine squared x, and as I've shown you in the previous question, remember your rule, 1 minus 2 sine squared x is cos double angle, right? So this is basically negative cos 2x. Now we want the period of this graph. Now we can see the period of this is just basically, you need to focus on this 2x here, because I've gave you the rules on top. Remember, if something is in this form, a sin bx or a cos bx, then the period is just 360 degrees divided by b. In this case, this will be period of this graph will be 360 degrees divided by 2, which is equal to 180 degrees. Moving on to question number 6, we have sine of x minus 180 degrees minus sine of 90 degrees plus x plus cos of negative x. Now we can write this down straight away because I've explained before. This is just basically cos x, right? Sine of x minus 180 degrees, we can use the negative angle, or you can just add a 360 inside here. If you add a 360 inside here, then you will be left with sine of 180 plus x. There's two ways to do it. You can use the negative angle. If you use the negative angle, remember, let me just do it in the side here. So we have x minus 180 degrees. If I use a negative angle, then we will have negative sine of 180 minus x, right? If you switch this around, remember, you will have a negative, and sine of negative angle is negative sine angle. And sine of 180 minus x will just give you negative sine x. Now this is the negative angle way to get negative sine x, and if the angle is negative, you can always add 360, and if the angle is more than 360, you can always subtract a revolution. So if I add a 360 inside here, I will be left with a 360 minus 180, which is 180. 180 plus x is in the third quadrant, and sine is negative in the third quadrant, so negative sine x. Rather do it, I like to do it this method. All right, obviously you can also use the negative angle method. And then sine of 90 degrees plus x. Now this is using co-ratios because we have a 90 degrees here. Now sine in the second quadrant is positive, right? So remember, this negative just remains negative. So sine in the second quadrant is positive, and sine changes to cos, so we have cos of x. Now you can clearly see that the negative cos x and the cos x cancel out, and my final answer is negative sine x. So you will be given A, B, C, D option. You select the correct option. Right. Let's look at question 7. If f of x, which is equal to sine x, is shifted 90 degrees to the right. Now guys, when you're shifting the graphs left and right, so if I have a function y is equal to sine x, and if I shift 90 degrees right. Okay, if you shift this graph 90 degrees to the right, then you will get a new function, which is y is equal to. Now when you shift the graph left and right, the domain changes, so we need to look at the x values here, or the x-intercepts changes as well. So x sine of, if you say 90 degrees to the right, so we need to say x minus 90, not plus, right? x minus 90 degrees. Right. So we have sine of x minus 90 degrees. Now remember, sine of x minus 90 degrees, we can simplify this. So if we use a negative angle if we use a negative angle, then we have sine. Let me just show you how to do the negative angle. You're going to take out a negative and you'll be left with 90 degrees minus x. Right. Now you know sine of negative angle, there's the angle. So sine of negative angle is negative sine of 90 degrees minus x, and 90 degrees minus x is in the first quadrant, so we'll just get negative sine, negative cos, because of 90 degrees that's a co-ratio, so we should get negative cos x, right? All is positive. So what's the final answer for this? The final answer, if sine x is shifted 90 degrees to the right, then the resulting equation is negative cos x. Okay, I've got two questions 7 here, so here's question 8. Right, let us look at question 8. Given sine 2x is equal to y, since sine 2x is equal to y and sine x is equal to z, what is cos x in terms of y and z? Right, so we want to find cos x. How are we going to go get cos x? We can look at the sine double angle. So let us expand sine of double angle. So sine 2x is equal to y, so we know we can expand this. So we got 2 sine x cos x is equal to y. Since we have 2 sine x cos x is equal to y, let us look at the rest of the story. We got sine x, we are given that sine x is equal to z, so we know sine x is equal to z. We can write down 2z times cos x is equal to y. Therefore cos x is now equal to y over 2 times z. And what did we want? We wanted cos x in terms of y and z. Obviously you will go and select the correct option from your given multiple choice. Question number 9, find the maximum value of k if k is equal to, we want to find the maximum value of k. If k is equal to sine of x over 2 plus 1 from minus 90 to 90. Now very important to note here is the domain of this function. Right, the domain of the function is x is an element from minus 90 to 90. Now we want to look at the graph of sine of x over 2. Right, if you look at the graph of sine of x over 2, let's see, let's sketch this graph here. Sine of x over 2, and then I want to shift this entire graph 1 unit up. So obviously if I'm shifting the graph 1 up, then let's see, if I substitute minus 90 inside here, so remember this original sine graph, it goes from this is the original sine graph, right? I'm just using y is equal to sine x, right? Now obviously if you sketch a graph of y is equal to sine 2x, then these points now become, remember this is just half a wave, so if we have sine 2x over here, sorry, let us look at sine x first. Let's look at this graph, y is equal to sine x. So remember you got 90 degrees here, 180 degrees there. You got minus 90 here and minus 180 there, right? That's your sine x graph. So just remember that. Right, so just want to shift this. We got y is equal to sine x graph. Now if I change this to y is equal to sine half x, not 2x, we have sine half x. then these points will now become, see, let's copy this just to show you what type of graph we will get. Right. Now remember the period now becomes the period of this graph, if I'm sketching y is equal to sine of x over 2. Now remember the period now becomes 360 degrees divided by half, which is 720 degrees. That's the period of this graph. So these points will obviously now change. Let me sketch this graph here. So just x and y axis. So remember the period of the graph is 720 degrees, so this is obviously 360 degrees, that is 180 degrees, this is minus 180, and thus minus 360 degrees. So you get one wave, right? Now we are interested in minus 90 degrees. So minus 90 degrees on this graph sine x is somewhere around here, right? Minus 90 degrees. And remember the value at 180 is 1 and the value at minus 180 is minus 1, right? Now what is the value at this point on the graph at minus, oh sorry, not minus 90, that should be 90 degrees. What's the value at 90 degrees and what's the value at minus 90 degrees? So minus 90 degrees is here, right? So we want to know these two values. So if we substitute in the original function, if I substitute minus 90 divided by 2, I'm going to get sine of negative 45, and sine of negative 45, so remember sine of negative 45 degrees is equal to minus 1 over root 2, negative angle, so negative on the outside because of the fourth quadrant, and sine of 45, so negative 1 over root 2. And if I substitute 90 degrees inside here, we get 45 degrees, which is 1 over root 2. So all we need to do here is we need to shift this graph 1 unit up. So if you want to find the maximum value, remember the range of this, the range of sine of x over 2 is minus half to half. Because it's a restricted graph, that's the reason why the range is from minus half to half. Therefore the range for this entire thing is y is an element, the range for f, right? Therefore the range for f is basically y is an element from minus 1 over root 2 plus 1 to 1 over root 2 plus 1. Okay, so remember in a range the min and max value, so this is the minimum value and that's the maximum value. The reason why the minimum and maximum value is like this is because it is a restricted graph. You only have to draw your graph from there to there. That's basically your sine graph, from here to that yellow portion here. So you need to focus on this yellow portion, which is, let's make it green here. All right, so that's your graph for from minus 90 to 90. The rest of the portion of the graph we're not interested in, right? Restricted graph. So that's your maximum value. Therefore max value is 1 over root 2 plus 1, and you select the correct option. So 1 over root 2 plus 1 can be simplified as, so this is a max value which is equal to 1 over root 2 plus 1, that's 1 over 1. So we got root 2 here in the denominator, and we got 1 plus square root of 2. You can rationalize, times the root 2 over root 2. Root 2 times root 2 is 2, and root 2 times 1 is root 2, and root 2 times 2 is plus 2. So that's how I would rationalize this. So either this is your solution, which is 1 over root 2 plus 1, or root 2 plus 2 over 2. You just need to look at the correct option. Let's look at question number 9. A ladder rests against a 4-meter wall, right? So let's draw a wall here. Right, so we've got a ladder resting against a 4-meter wall, right? So call this the ladder, that's the wall, at an angle of 30 degrees, right? So rest against the wall, so this is the ground, right? So that angle is 30 degrees. If the ladder slips 1 meter down the wall, right? So slips, so it was 4 meters, right? Now looking at new scenario, so that, okay, let's take this out. The same diagram we can say, right, so now the ladder is somewhere around there because slips down 1 meter down the wall. Then obviously this length of the ladder does not change. If it slips down 1 meter, it's going to slide away this way. So let's see, angle of inclination is, what's the new angle of inclination, right, between the ground and the ladder? So let us work that out. Remember, the length of the ladder does not change, so your new angle of inclination is somewhere around here. Okay, let's call that theta. That's what we want to find. Of course, that is 90 degrees. So first we want to find the length of the ladder, right? So the length of the ladder with respect to the original question would be sine of 30, because we got opposite hypotenuse. Sine of 30 degrees is equal to 4 over L, right? 4 over the length of the ladder, and L, therefore L is now equal to 4 over sine 30, and sine of 30 is half, right? 4 divided by half is the same thing as saying 4 times 2, so the length of the ladder is basically 8 meters, right? So this ladder did not change when it slipped down the wall, so this is also 8 meters here, right? And this is also 8 meters till the ladder here. Now looking at this line over here, we got theta, right? And we also have the length from here to there, right? So the ladder is slipped down 1 meter, so now the distance from the ground to the top of the ladder is 3 meters. So we got 3 meters, we have 8 meters, so we can write down sine, we got opposite hypotenuse, again opposite hypotenuse, so what we have is sine theta, which is the angle of inclination, is equal to 3 over 8, right? And then obviously we can't really find 3 over 8, so we can just write theta is equal to, because it's not a special angle, so sine inverse 3 over 8 should be your angle of inclination. If this was a special angle, then you could have worked out the correct answer, right? Right, let us have a look at question 10. Sam and Tom start cycling from point A. Sam cycles at a speed of 24 kilometers per hour. So Sam's cycling speed is 24 kilometers per hour. Right, so let's just highlight some. 24 kilometers per hour, that's Sam, and 32 kilometers per hour, which is Tom. 24 kilometers per hour in the direction of north, 15 degrees west, right? So 15 degrees west, northwest. And Tom cycles at 32 kilometers per hour in the direction north 45 degrees east. Calculate the distance between Sam and Tom after 15 minutes. So after 15 minutes, remember this person is going at 24 kilometers per hour, so we need a new diagram. you can see the when you calculate the distance between them, so the distance between them will be, just say, from here to there, right? So we can just call that d, and we can get this distance, let's call this a b c, right? So AB's distance we can find because this Tom is cycling at 32 kilometers per hour, and this person travels 32 kilometers in 60 minutes. So we want to know in 15 minutes. In other words, we're dividing this by 4, so we need to divide this by 4 as well. So 32 divided by 15 should get 8 kilometers per 15 minutes. So this person traveled 8 kilometers, so we got 8 here, right? Remember the angle between them is 60 degrees, and we're going to calculate the distance there, right? And A to C, which is Sam, which is 24 divided by, remember after 15 minutes, 24 kilometers in 60 minutes, so divided by 4, 24 divided by 4, we got 6 kilometers here. So to calculate the distance, remember the information that we have is side, angle, side, right? To calculate the distance between Sam and Tom after 15 minutes, we can use the cosine rule, which is d squared is equal to 6 squared plus 8 squared minus 2 into 6 into 8 cos of 60 degrees, right? So d squared is equal to 6 squared plus 8 squared, that's 36 plus 64, which is 100, minus we have over here, which is, okay, let's try to simplify this further. So you can see cos of 60 is half, right? So remember, cos of 60 is basically half, and a half times 2 cancels out, so we got 6 times 8, which is 48, right? And over here we got 52, 100 minus 48, so d squared is equal to 52. And then d, since d is positive, we can leave out the plus and the minus, right? So 52 is basically 4 times 13, so d will be square root of 4 times 2 root 13. That's the correct answer, and you should be able to select this from your multiple choice, or right. So guys, we have 10 questions here. We just have one more left, right? So I'll try to do that in my next session. All the best, guys, for your NBT exams for the year 2021. If you do have any queries, or you want me to do all the other questions, right, please contact me and I can help you out. Take care, guys. Thank you. Bye.